In this video, we will see a few more examples on differentiating very complicated functions, right? Let's see 3 examples. The first function here, y equal to square root 2 minus e to x over tangent of x. Right? What we want to evaluate y prime, right? So y prime here. And I can see that we need to use all the rules we have before, quotient rule, difference rule, right? And constant derivative is 0, right? And also chain rule for sure. And quotient rule first, because look at this function, you see a quotient first, right? So this is take the derivative, take the okay, let me change my denominator a little bit. So that should be 2, right? 2x. So tangent 2x, then square, right? When you apply quotient rule, the derivative of the numerator, 2 minus e to x prime times tangent of 2x minus square root 2 minus e to x times tangent 2x prime, right? So this is basically how do we apply our quotient rule, right? When you try to differentiate the numerator, you can see that that's a combination of 2 functions. Inner function is 2 minus e to x. Outer function is square root, right? Just we know how to differentiate square root function. We know how to differentiate inner function. Just put them there, right? So this is 1/2 2 minus e to x to the power negative 1/2 times the derivative of 2 is 0, and derivative of e to x is e to x, right? Times tangent of 2x minus square root 2 minus e to x times tangent 2x inner function, tangent outer function. The derivative of tangent is secant squared. So this is secant square of 2x times the derivative inner function, which is 2, then over tangent of 2x squared, right? So this is our first example, right? Okay, now let's see. Let's see 2 more examples. So let's try to write down the derivative. Try to make sure we write down the derivative in one step and correctly, right? X squared plus 1 to the power 6, right? And now you can see that this function is a combination of 2 functions first, then the inner function is a quotient. So clearly we want to use quotient chain rule first, then quotient rule, right? So h prime of x is outer function is to the power 6, is a power function. So bring down the power 6 and keep inner function x squared minus 1 over x squared plus 1 to the power 6 minus 1, which is 5. Then when you try to differentiate inner function, we want to use quotient rule, right? So which is x squared plus 1 squared 2x x squared plus 1 minus x squared minus 1 times 2x, right? This is how do we differentiate the inner function. Okay, one more example for this video will be this. So f of u, right? The variable can be any letter you want. You can differentiate about u here, 5, 3 u plus e to negative u over tangent root u, right? So look at this function first. It's a quotient first. Both numerator and denominator are contains the combination of function, right? Here we need to recall that a to x prime is a to x times natural log of a when you have a is positive, right? So let's try to calculate f prime of u. And the denominator is tangent of root u, then square as always, because we apply quotient rule. And the first factor, if you differentiate that, you get 5, 3u times natural log of 5, right? And differentiate inner function because that 3u is the inner function, then times 3. Then plus e to negative u, inner function is negative u. The derivative of negative u is what? Is -1, right? Times -1, then times tangent of root u. Then you subtract 5 to 3u plus e to negative u times derivative of the denominator, which is secant square of root u times 1/2 u to negative 1/2, right? This is basically the derivative of this function. Looks very complicated, but as long as we follow all the rules step by step, we can get the derivative correctly, right?